We've seen many of the nice properties of symmetric matrices, and we've seen how to orthogonally diagonalize them. Symmetric matrices appear in certain functions called quadratic forms that are useful in many applications. Okay, so we're going to look at quadratic forms. A quadratic form on Rn is a function q from Rn to R given by q of x equals x transpose A x, where A is a symmetric matrix. For example, let A equal this, and let Q from R2 to R be given by this, find Q of x1, x2, okay, so Q of x1, x2 is equal to x transpose okay, so here x is a column vector, so when we take the transpose we get the row vector times A times x. Okay, so that's going to be x1, x2 times this. If we multiply this out, we get 2x1, 6x2. Okay, now multiply this out. Okay, and note that the coefficients of x1 squared and x2 squared are the diagonal entries of A. So here we have 2 and 6. Let's do another example. Let A be this matrix. And let Q from R2 to R be given by Q of x equals x transpose AX. Find Q of x1, x2. Okay, so that's going to be X transpose times A times X. Okay, so we get x1, x2 times this. If we multiply that out, we get negative 4x1 plus 7x2, 7x1 plus 5x2. And now multiply this out. x1 times that plus x2 times this. Okay, simplifying. And I get this. Note that the coefficients of x1 squared and x2 squared are the entries on the diagonal of A. So here we have negative 4 and 5. So we get negative 4x1 squared and 5x2 squared. The coefficient of the cross product term x1, x2, that comes from the entries off the diagonal of A. Here we see 7 and 7. Okay. We see here that we had 7 x1, x2 and another 7 x2, x1. When you combine them, you get 14 x1, x2. Now, in the previous example, we had A equals to this, and the entries off the diagonal are 0. So Q of x1, x2 had no cross product term. Okay, it had no term like x1, x2. Okay, let's do another example. Let A be this matrix. Let Q be the function from R3 to R given by Q of x equals X transpose AX. Find Q of x1, x2, x3. Okay. Q of x1, x2, x3, that's equal to x1, x2, x3 times A times x1, x2, x3. And that's equal to x1, x2, x3 times this when you multiply it out. Okay. Now multiply this out. Okay, and so we get negative x1 squared plus 2x1 x2 plus 5x1 x3 plus 2x2 x1 plus 4x2 squared minus 3x2 x3 plus 5x3 x1 minus 3x3 x2 plus 3x3 squared. Okay, now look here, we get negative x1 squared here plus 4x2 squared plus 3x3 squared plus, now look at the terms off of this diagonal. So here we have x1, x2, and we have 2x2, x1 here. So that's a total of 4 x1, x2. Here we have 5x1, x3. And here we have 5x3, x1. So we have a total of 10 x1, x3. Here we have minus 3 x2, x3 and minus 3 x3, x2, giving us a total of negative 6 x2, x3. Okay, note that the coefficients of x1 squared, x2 squared, and x3 squared are the diagonal entries of A, and the coefficients of the cross product terms xij, xij are twice the entries A sub ij off the diagonal of A.